Hey everyone, I hope you're doing well today. In this video, let's go ahead and do some practice problems with creating area models for multiplying and dividing fractions. So for this first example, let's go ahead and try something like, 2/3, and then let's multiply that by 3/4. Okay, so we could just multiply this straight ahead first and then see if the area model matches, and I think that's what I'll do here. So one way you can multiply is just multiply the tops here. So 2 times 3 on top and then 3 times 4. You're going to notice that you'll get 6 on top and then 12 on bottom. Then if you go ahead and divide top and bottom by 6, which is their GCF, then you can get the most fully simplified fraction here of 1/2. Again, if you didn't do it this way, that's also okay. You might have done a little bit of cross canceling, and that's also totally okay as well. So maybe you can see that this 3 and 3 have a GCF of 3, so you can divide them both by 3 to get 1s here. And then you can divide this 2 and 4 both by 2, and you'll get 1/2. All right, so if you go ahead and just multiply the tops here of 1 times 1, and then multiply the denominators here of 1 times 2, then you're going to get a fully simplified product here of 1/2 as well. So to get started on our area model, what we do is we start by drawing some sort of rectangle or square. Either one is okay. I'm going to do a rectangle here, and so this is going to represent our 1/2, okay? And we start by looking at this first fraction of 2/3, all right? And the most important thing to look at is its denominator first, so that's how many pieces we're going to cut this rectangle into. So we have thirds. So maybe I'll draw one line here and another line here. So keep in mind, if we are cutting into thirds, we need 2 vertical lines. So here's the 1/3, here's another third, so that represents here our 2/3. So let me go ahead and shade here is 1/3, and here's 2/3. Okay, so there we have our 2/3 for our first fraction, and then let's go ahead and multiply that by our 3/4 here, and let's take a look at the denominator of 4. And so going across, that's how many rows we're going to have. So let's go ahead and divide this once, so that's halves. And if I draw another line on top and another line on bottom, now you're going to see hopefully that we have fourths. So here's 1/4, here's 2/4, here's a 3/4, and here's 4/4. Okay, so now we have 3/4 going across, and how do we shade that to show? Well, I can just go ahead and shade one of these rows. Shading one of them gets us 1/4 of the rows. Here we have 2/4 of the rows, and then here we have 3/4, or 3 out of the 4 rows. Okay, so how do we then kind of identify how this whole answer works out to being 1/2? Because we already solved the problem. We go ahead and take a look at how many of these little rectangles got shaded twice. So here's one, here's a second one that got shaded twice, here's a third one that got shaded twice, a fourth one, a fifth one, and a sixth one. So out of all the rectangles here, which there are 12, right? So there's 1, 2, 3, 4, 5, 6, 7, 8. Then we have 9, 10, 11, and 12. Out of these 12, there are 6 of them that are shaded twice out of the 12, and that simplifies down to being 1/2. So there's one example, and maybe let's go ahead and try another one with different types of numbers. So maybe a mixed number in here. So let's try doing 4.5, and let's multiply that by, 1/3. Okay, so we need to take 1/3 of 4.5 of something. So I'll go ahead and multiply this out normally. So multiplying, okay, this 4 times 2 is 8 plus 1 is going to be 9. So we need to have improper fractions or proper fractions. So we have 9/2 multiplied by 1/3. Okay, and at this point what you can do is you can just multiply 9 times 1 on top to get 9, and 2 times 3 on bottom to get 6, but then you have to divide them both by their GCF, which is going to be 3 in this case. So the most simplified version here is going to be 3/2, also known as 1.5. Okay, so that's one way to do it. If you want to cross cancel though first, which is going to be hopefully the way you go about it in the future, as you get the hang of it, 3 and 9 have a GCF of 3, so you can divide them both by 3 to get 1 and 3. And then just multiplying the tops here, 3 times 1 and 2 times 1 on bottom, then you should get the most simplified version right away, which is 3/2, also known as 1.5. All right, so either one of those are okay. So again, this is going to be the answer to this multiplication problem. But let's see if we can go ahead and visually show what this looks like. Okay, so let's go ahead and draw an area model now. So starting with this fraction of 4.5, we really want to draw something that represents 4 wholes and then a half. So here I'm going to draw this. This rectangle is going to represent 1 whole, and we need 4 of these entire things. So here's one of them. Here's a second one. Here's a third one. I know I'm cheating a little bit with my tablet. And then we need a 4th one here. So I'm going to go ahead and draw, or a 5th one, sorry, 5th and a half of a 5th one, I guess is what I meant to say. So now that we have our 4.5, if we had all of them, right, then we would shade them, just fill them all in. So here's 1 whole, and then here's a second entire thing, and then this is a third entire thing, or third whole. Here's a 4th one, and then here's the half. So 4.5, I don't know what you want to call them, maybe 4.5 candy bars, that's perfectly fine. And then you take a look here, and we're taking a third of them. Okay, so we're gonna have to take a third of all of these things. Again, if you're not sure how do we kind of know it's of, multiplication is always gonna be represented by of, especially if you give it some context. So we're saying we're taking a third of these things. So how can we go ahead and show that this represents 1.5 as our final answer? Well, if we take a third of all these pieces, so let's go ahead and just take a third of this one. Okay, if we take a third of this first piece, that's just going to be represented right here. That's 1/3. If we take the second piece and also take a third of it, that would be something like that. Then another third would look something just like this. And then another third would look something like this. Okay, for this last one, what we would do is we would take this and break this into a third as well. But keep in mind, this third is smaller because, you know, it's just a smaller piece overall. So I guess the question is, you know, how do we get our total answer of 1/2? So this is a little bit tricky to kind of visualize. So I'm going to try to be very, very careful with how I draw this. But notice how all the pieces are drawn. So if I go ahead and break these into the same size pieces as the one down below here, this one kind of dictates because it's smaller. So we're going to break them down into smaller pieces. So it looks like we're going to break them all into these sixths instead. Okay, so right now we created everything is going to be the same exact size pieces. Okay, so let's see like how many of them are actually being shaded in here. So this right here, hopefully that makes sense, that we can see this is 2 out of the 6, which is still the 1/3. Okay, right over here we have another 2 out of 6, which again is 1/3. We have another 2 out of 6, that's right over here. We have another 2 out of 6, they're all the same thing. And whoops, I wrote 2 out of 3, so that should be 2 out of 6. And then this last one here is really just 1 out of 6, right? Just keep in mind it's out of the whole thing, so it's the same size piece there. If we wrote 1/3, that would be too big. Okay, so well, let's see here. If we take this this 2/6 here and we add it onto this 2/6, that would be 4/6. Adding it onto this 2/6, that would be 6/6. Adding another 2/6, that would be 8/6. And adding one more on, that would be a total of 9/6, just like that, right? And if you go ahead and simplify this and divide the top and bottom both by 3, divide this by 3 and divide this by 3, you'll see that this will be 3/2, also known as 1 and 1/2. So there you have one way of kind of drawing an area model to represent that if you have 4.5 and you multiply that by 1/3, it's equal to 1.5. Now, another way you could kind of draw an area model to visualize the same problem, if that one doesn't make as much sense to you, is we can draw 4 holes again. So here, this is going to represent 1 hole, okay, or 1 entire something. Let me go ahead and duplicate this, so I'll copy that. Here's a second entire thing. Here's a third one, and here is a 4th one. And then for the 5th one, we don't have the whole thing, we just have half of it. So I'm gonna go ahead and draw this dotted line down the middle to show you that we don't actually have the entire thing. Okay, so let me kind of like, I don't know how to grade that out here. I'll try to let you know that this is not actually here. Okay, so we're just looking at the left pieces here. Okay, that's 4.5. Now, if we are cutting it into thirds, right, then what we're gonna do is we're generally just going to be saying, okay, let's cut this whole thing, that's 1/3. And then let's go ahead and cut it one more time, so that's now 2/3. Okay, so we now have all these third pieces here. So if we take a look and see like what is actually showing 1/3 of all of that, well, here's 1/3 of this one. Here's another third. Here's a third. Here's a 4th third. And then what is this? Well, let's think about that. That's 1 out of this whole 6, right? There's 6 little pieces here. There's 1, 2, 3, 4, 5, 6. There's 6 pieces, so that's 1/6. Over here we have a third of this one, a third of this one, a third of this, and a third of this. So what happens when you combine all of these ones here? All of these thirds are going to make one whole. And if you go ahead and add these 2 pieces here, just keep in mind that this 1/3 right here is the same thing as 2/6. So if you add 2/6 plus 1/6, that's 3/6, which is also known as 1/2. So it looks like 1.5 would be the same answer either way. So there's a couple multiplication examples, so let's maybe try a couple division ones. So let me get rid of all this stuff. So for an initial division problem example, let's maybe take a fraction like 3/4, and let's divide that by 3, something pretty straightforward here. So before I draw the area model, let me just go ahead and just divide as we do normally, so you can kind of see what the answer is supposed to look like when we're done. And so when we divide fractions, we don't like mixed numbers or whole numbers, so 3 we can rewrite as 3 wholes, or 3/1. And then keep in mind that to divide all fractions, it turns out we can solve them by just rewriting them as a multiplication problem. So we keep the first fraction, and then we change division to multiplication, and then we reciprocate the second fraction. So it's going to be 3/4 times the flipped version of the second one. So if we go ahead and rewrite it like this, we can then go ahead and solve this, right? So we can cross cancel here. It looks like we could cross cancel the 3 and the 3. And so you can divide them both by 3 to get 1s. And then if we just go ahead and multiply this 1 times 1 on top, and then multiply this 4 times 1 on bottom, then we can get a fully simplified fraction here of just 1/4. Okay, so if we take this 3/4 divided by 3, that is equal to 1/4, but let's see if we can show this using a model. Okay, so maybe I'll draw something that looks like one whole of something. So imagine this is like one whole candy bar, or one whole of something, hoagie, I don't know. And so we have this entire thing that's one whole. And if we take a look at this first fraction of 3/4, then we need to break this into 4 equal pieces. So if I break this in the middle, that's now half and half. If I take half of that and half of that, that's now 4 equal pieces, right? We have 3 of them, so 3 out of these 4, let's go ahead and shade in. That's going to be 1/4. Here is now 2/4, and then this is going to be 3/4. Okay, so we have 3 out of 4 pieces here. Now, if you have 3/4 of this entire thing, if it's an entire sandwich or an entire candy bar or something, we have to take this now and divide it into 3 equal-sized groups, okay, to share amongst 3 people. So what would fit into 3/4 3 times is what we're asking ourselves here. All right, so we can say, okay, let's break this into 3 equal groups. So if we take this entire thing, which is right here, this is what you have. You don't have the whole sandwich, you have 3/4 of it, and this has to be shared amongst 3 people. Well, if we divide it down here and divide it down here, this is going to be our 3 different pieces that we can share. So what fraction is one of these? Well, this is 1/4 of the entire thing. This is 1/4 of the entire thing. This is 1/4, and then this is 1/4. So what we're saying here is our final answer is going to be 1/4, because that's what fits into 3/4 3 times. So just to make this full circle, if we say that 3/4 divided by 3 is equal to 1/4, then we should be allowed to say that 1/4 times 3 is equal to 3/4, right? Again, multiplication and division are inverse operations, so if you divide one way, you should be able to multiply back the other. And so this does make sense, because 1/4 times 3, or 1/4 times 3/1, the 1 times 3 on top is 3, and the 4 times 1 on bottom is 4, so this does work out. Okay? All right, so there's one division example. Let's try maybe just one more. Okay, so try to keep this video a little on the shorter side, just a few different examples, 2 multiplication, 2 division. All right, so let's try something like this, where we have 4.5, and then let's divide that by 1/4. And let's try to see if we can figure out what that is. So how would we do this without using an area model? Well, we don't like improper fractions, or we don't like mixed numbers rather, so let's do 4 times 2, which is 8, plus the 1 is going to be 9. So 4.5 is the same thing as 9/2, and we're going to divide that by 1/4. Okay, keep in mind, just like in the last example, we want to think about this as a multiplication problem, so we can rewrite all division problems as a multiplication problem to get the same answer. So we're going to keep the 9/2, and we're going to multiply by 4/1. That's the reciprocal of the second fraction. Instead of just multiplying and then simplifying, let's simplify then multiply. So we can divide these both by 2. That's going to be 1 on bottom, 2 on top. And what are we left with? Well, on top we have a 9 times 2, and on bottom we have a 1 times 1. So on top, 9 times 2 is 18. On bottom we have 1, and that simplifies down to just being 18. So it turns out that 4.5 divided by 1/4 is equal to 18. But how do we show that, right? That's kind of the thing that we want to go ahead and do here. And so we have a mixed number. We want to try to show what 4.5 looks like. So I'm going to go ahead and draw what one whole looks like, or one entire thing. So let's call that one whole. And we need 4 of these, right? We need 4.5 technically. So here's 1, 2. Here's a third one. Here's the fourth one. And we need a half. So let me go ahead and break this one down in half so we don't actually have the last piece. Okay, so let's go ahead and just like X this out and try to pretend it's not there. But that way you can see that this is the 4.5. And if we know that we're dealing with half-size pieces, what I strongly recommend doing is just going ahead and breaking all of them into the same size and same pieces. Again, it's still 4.5. This way, though, hopefully you can see that we do have 9 of these halves, right? We have 1 half, 2 halves, 3 halves, 4, 5, 6, 7, 8, 9 halves, which is, the whole reason why 4.5 is the same thing as 9 halves. Those are equivalent to each other. So now that we can see the entire 4.5, let's try to then understand how we're fitting in this 1/4 size piece. We're saying how many times does it fit into 4.5? Again, that's what division is, right? How many times does something fit into something else? So this 1/4 size piece. So let's go ahead and actually divide each of these holes into 4 pieces. Okay, so we have 4 identical looking pieces here, and then we have 4 over here. Again, just drawing these lines is showing that we're breaking them all into quarters. Even this bottom one here. All right, so we're saying how many of these fit inside of 4.5? Well, here's 1, here's 2, here's 3 and 4. That makes sense. There's 4/4. And then how many can we fit here? 5, 6, 7, 8, 4 more. We can fit a 9th, 10th, 11th, and 12th one. And then we have a 13th, 14th, 15th, and 16th. And finally, you can see that we have a 17th and 18th piece as well. Right, so there hopefully you can see that this is the amount of times it fits in. So we have 4.5 holes, and if you divide that by 1/4, we're saying it fits in 18 times. Right, that's basically what we're saying here. If you want to go backwards, we should be able to say, well, 18 times these quarters, or if you have 18 of these things, again, I said earlier that this multiplication is always meaning of. You have 18 of these things, and that's going to equal 4.5. Right? If you're not sure if that actually works, let's do 18 over 1 times 1 over 4. We could probably do a little cross canceling here. We got 2 even numbers. Divide these both by 2. We get 2 and 9. And if we multiply 9 times 1, that would be equal to 9. If we multiplied 1 times 2, that would be equal to 2. And 9.5 is the same thing, or 9 halves rather, sorry, is 4.5. So you can see this does work out nicely. All right, so there's 2 examples of creating area models for multiplication and 2 examples for creating area models for division. So hopefully going through these examples helped you out a little bit. So good luck with your studying and practicing of these, and hopefully the visuals were helpful. And as always, keep up the great work, and I'll see you in the next one.